So it was a bit hasty to cut off that last recording. This was the image that would have given you the picture of what I was talking about as we finished up our discussion about the alimentary canal with the large intestine. Also, at the beginning of this second part of the video, it's a good time for me to plug that maybe the digestive system is a great system for you to do a concept map on. I'll try and give that a bit of a plug at the beginning of each chapter as we go through all the systems of the body. But we're going to just round out our discussion of the digestive system with a little bit of nutrition. And so your textbook talks about how a healthy diet can satisfy 3 needs. Other resources, and I think the videos even say there's 2 needs. So the one is basically calories, enough fuel for the body. So we're talking about enough energy here, or calories. And then these ones are sometimes lumped together. So you need the basic material. So you need monomers to build things up, right? To build important biological molecules. And your textbook also says that there are essential nutrients. And so those are not necessarily monomers, but they're raw materials that animals can't make for themselves that you have to ingest. This is me. I really do think that beyond what the text says, I really love food. And I think it is possible to consider another need that food satisfies for humans. And I think there are social and emotional needs met through food, quite honestly. This is my opinion, hence the smiley face there, not from your textbook, but I think that food is a really important component for humans. The chemical energy is really what we're talking about with the fuel need there. So nutrients are oxidized inside the cell. They're basically digested or put through cellular respiration to make ATP. Hello, chapter 6. All of that. That's the key thing here. This is the energy for the body. So we talk about potential energy or calories in the nutrients or the molecules that are broken down, if you want to think of that as broken down, or sent through chapter 6 in cellular respiration. We know that ATP is the main currency of the cell, so we talk about it as being somewhat synonymous with energy. We know that proteins, carbohydrates, and fats are the main sources of dietary calories. Those are the three of the macromolecules. Nucleic acids are not listed there. If you were to talk about which one's the biggest, fats have roughly twice as many more calories as do carbohydrates or proteins. So gram for gram, you'd get twice as many calories in 1 gram of fat than you would in proteins or carbohydrates. So that's why it's easy to, eat not a whole lot of, say, bacon or butter or any of those kind of things, or coconut oil, and you do get a lot more calories per gram out of that macromolecule. The basic energy needs would be your basal metabolic rate, and your basal metabolic rate is just the stuff to keep you alive. Doesn't allow you to do very much, but you do stay alive. So that's your basal, it's your base level. Your metabolic rate is your basal metabolic rate, the stuff that keeps you alive, plus your activity. So the energy that's required for you to go about what you need to do in a day. If you eat more energy than your metabolic rate burns, then you're going to store that energy in 2 different ways. So you're going to top up your glycogen stores, making that polysaccharide of glycogen stored in the liver, or store those excess calories or excess energy in fat cells. Our metabolic rates typically decrease throughout adulthood, something that I have noticed. Take a look at your parents, because that seems to be what happens to us, whether we like it or not. One of the reasons I didn't put myself in the videos, because I did some videos and I was like, wow, why is my mom teaching biology? Anyway, so it does change throughout life, usually linked to hormones and age. And this is a news flash. The more you do, the more calories you burn. So a healthy and active lifestyle burns more calories. Basal metabolic rate for a female is roughly 1,500 kilocalories per day. Kilocalorie, I talked about this earlier, is really a capital C calorie. So it's what we talk about like on, a granola bar wrapper or whatever. The nutritional world replaced kilocalories with big C calories. And for a male, more, basically based on weight, not that they're just doing more. 16 to 1800 kilocalories per day. If you've ever had a Fitbit or a watch or something that kept track of things, that's arguably um, reliable or not, I don't know, but you can kind of keep track of what you've been doing and how much energy would have been burned. Back in the day before the Supersize Me, do you remember that McDonald's documentary? Where the guy went and ate McDonald's every day for, I don't know what it was, a month or whatever. I had a grade 9 science class in Thunder Bay, Ontario, and I told them that they had to track their activities for 3 days. And then I handed out the McDonald's menu that has all of the nutritional details of the foods. And so then they had to do an energy calculation to calculate how much energy they were burning with their daily activities, and with a fantasy 3-day McDonald's menu. Maybe that's a nightmare for some of us, but for a 14-year-old, that was a fantasy menu. They could calculate if they were at a surplus of calories or a deficit of calories. And newsflash, most of them were at a surplus of calories after eating only McDonald's for 3 days. So an animal's diet must supply essential nutrients. So it's not just the fuel, it's not just the caloric content that we need. Essential nutrients can't be made from raw materials, so we have to ingest them. So our body can't make these for ourselves. So if you have malnourishment, that means that you're missing essential nutrients. And oftentimes, you can be overweight and still suffering from malnourishment. That's that idea that there's the two basic concepts here. So if you really are starving for calories, so the first criteria of what the diet is doing for our bodies, not getting enough fuel, that's true starvation. So that's undernourishment. So mal meaning not good nourishment, where under being insufficient energy from our food. So not enough food. So animals can't produce 8 of the 20 amino acids. So that means that we have to ingest them from other sources. So our body can make the other number of amino acids, but 8 of them we have to get from ourselves. So 8 of the amino acids are essential amino acids, and they have to come from the diet. We can eat other meat, we can eat other animals and get all of those in one serving. Vegetarians have to make sure that they combine foods in order to get all 8 of those essential amino acids. It's not hard to do, but that idea that there can be, a one-hit wonder with eating other animal proteins, because they would have all 8 of those essential amino acids, or the proper combination of plant foods. And the classic rice and beans, or beans and corn, is a way of getting all of those essential amino acids. There are essential vitamins and minerals, so we don't need a whole lot as far as amounts of these. For some of these, extreme excesses can be dangerous. The key here is that in vitamins, we could have water-soluble vitamins or fat-soluble vitamins. Fat-soluble vitamins are more dangerous. So if you have too much vitamin C, you would simply get rid of it. It could be excreted in your urine. But if you have too much, example, vitamin E, it could accumulate. And so the body can easily get rid of an excess amount of water-soluble vitamins, but it can't excrete the fat-soluble vitamins as efficiently. And so what it does is it stores them in the fat of you so that it can metabolize them a little bit at a time. And so, an excess of vitamins is possible, less likely for those water-soluble vitamins, and potentially more possible for the fat-soluble vitamins. On top of the vitamins, there are also minerals required. And so minerals are simple inorganic nutrients, so meaning they don't contain carbon. So salt is an example of that. So calcium, phosphorus are needed in larger amounts. And most people consume more sodium than they need. And that's what we're talking about in salt as we know it. There are some charts in your textbook. On your review pages, it asks you to summarize a smaller number of these. For summary and information on vitamins and minerals, I would recommend you choose ones that you already know something about. And so here I picked vitamin C and some B vitamins and folic acid. These are ones that are water soluble, and I've listed out, what you get them in your diet and the functions in the body. The other thing here would be symptoms of deficiency or excess. So the excess is in the green, and you'll notice that many of these don't have any excess symptoms. Gastrointestinal upset. I know that. I've had a child fall in love with those little Christmas oranges and eat far too many of them as a toddler. And I was warning them all along, don't eat too many oranges, or something bad's going to happen. And that gastrointestinal upset, saying it nicely, is what happens if you do eat too many of those little Christmas oranges. Yeah, so you'll notice there are not a lot of symptoms of excess because the water soluble vitamins are easily excreted. Fat soluble vitamins, again, I just picked some here. Others could be summarized. There are there's lots of information in the charts in your textbook. You are asked again to kind of reduce this number on your review pages. Vitamin A, vitamin E could have been picked here. D and K are ones, and you'll notice that almost all of them have some symptoms of excess. And so these being the fat soluble vitamins, excess amounts are stored in the liver or in fat tissues. The last one would be the minerals, and I haven't filled in this chart. This is the chart from your textbook. So again, I would choose the ones that you are most familiar with. So calcium is often a supplement that people have taken. Maybe calcium, magnesium, or iron are ones that you have taken as a supplement. So those might be the ones that you want to summarize in a table, something like this. You do have this information in your textbook, just like the previous slide. And I've left this one blank in the PowerPoints because you're going to fill one in like this on your review pages. So with the digestive system, don't forget this might be one that you want to make into your concept map. And we're going to move on. The next one, there's no lab for this one. The next one would be our respiratory system.